Today we're going to be multiplying polynomials, and we're going to start right off with an example and show you step by step how to do this type of problem. First thing you need to know is that multiplication, when we're talking polynomials, is a big distribution problem. So all we're doing here is distributing to begin with. So when we distribute, notice I have two terms in the first polynomial or a binomial. I have three terms in the second polynomial or trinomial. So I'm going to take both terms or all terms of the first polynomial and distribute them to all terms of the second polynomial. So if you're super confused, hang on. We're still going to go through this. Give me just a second. We're going to start by distributing the first term of the first polynomial. So in other words, I'm going to distribute that negative 5x. I'm going to start by distributing it to the first term of the second polynomial, right? All terms of the first goes to all terms of the second. So I need to multiply these two terms together. When I multiply terms, I do not have to follow the same rules as addition and subtraction. I do not need to have like terms in order to be able to multiply. So when I multiply terms, just a quick reminder, I multiply signs, I multiply coefficients, and I'm multiplying all the variables together. So in my negative 5x, remember that's the same as x to the first power right here. That means I only have one x that's getting multiplied to the negative 5. In my 3x squared, I have two x's that are being multiplied to the 3. I need to keep track of how many x's there are so that I can multiply them in just a second. So when I multiply, the easiest way I can come up with is to look at signs first. What's a negative times a positive? Hopefully you know that that's a negative, right? Then I look at the coefficients, 5 times 3. That gives me 15. And then I have to multiply all my x's together. So I have an x times an x times an x. That's going to give me x to the third power. So I end up with negative 15 x to the third power, just by multiplying those first two terms. Moving on, now I'm going to distribute the negative 5x to the negative x. Negative times a negative gives me a positive. 5 times the 1 in front of the x gives me 5. And x times x gives me x squared. So I have a positive 5x squared. Next, I have to distribute the negative 5x to the positive 4. Negative times a positive is a negative. 5 times 4 is 20, and I only have one x involved, so negative 20x. I'm not done yet, right? Now I've distributed the first term to the whole second polynomial. What do I need to do next? What am I missing? Now I need to distribute the next term, or the positive 2, to the whole second polynomial. So I'm going to distribute the 2 to the same terms that I distributed the negative 5x to. So I'm going to say positive times a positive is a positive. 2 times 3 is 6. And I have those two x's, so I'm going to bring them down. Positive 6x squared. Next, I need to distribute to the negative x. So positive times a negative is a negative. 2 times the 1 in front of the x is 2. And I only have one x. And the easiest part, 2 times 4 is positive 8, right? So now my distribution is done. Just a quick side note, notice I have two terms being distributed to three terms. 2 times 3 is 6. When you distribute, you should end up with those 6 terms, just so you can make sure that you're not missing any. Now, I'm close to being done here, but not quite. I have all my distribution done, But now I need to combine like terms and put my answer in descending order. So let's look at any like terms that we have first. I only have one x to the third power term, so I bring it straight down. I have two x squared terms. I have 5x squareds being added to 6 more x squared, so I have 11x squareds. I have two regular old x terms, negative 20x's, and I'm subtracting 2 more x's. That gives me negative 22x. And I only have one constant, so it gets to come straight down. Now I don't have any more like terms in my final solution. I need to check and make sure that it's in descending order. If it is, you're done and my problem is complete. Let's go through one more quick example and then I'll let you go. So now I have a binomial being multiplied to another binomial. 2 times 2 means that after I have all my distribution done, I should have 4 terms. So let's get to work. Distributing the first term to the whole second polynomial, I have x to the third times negative x squared. Positive times a negative is going to give me a negative, and I have 5 x's being multiplied together. That's going to give me negative x to the fifth. I need to remember to distribute it to the positive 11, and that just gives me positive 11x to the third power, right? There's no x's to combine. Next, I need to distribute the positive 9x. Distribute it to the first term. Positive times a negative is a negative. 9 times 1 is 9. And how many x's are we going to end up with? 3, right? So negative 9x to the third power. And finally, 9x gets distributed to the 11. 9 times 11 is 99, and there's only one x involved between the two terms. One thing that might help you out here is that remember that coefficients get multiplied, and if you pay really close attention, your exponents are being added. So coefficients get multiplied, exponents get added when we're multiplying terms together. Now all my distribution is done. I have the 4 terms that I decided I needed, right? What's my next step? What's my last step when I'm multiplying? Now I need to look at combining like terms. My only like terms here are the 2 x cubes in the middle. If I have 11 of those and I take away 9 of them, I'm going to end up with positive 2 x cubes in my final answer. The other terms that don't have like terms to combine with simply get included anyway. Make sure your answer always ends up in descending order. If that's the case, you're done. Make sure to write down any questions that you have so you can remember to ask them in class. Remember that definitions and examples are super important to go in your notes. Have a great day, and I'll see you in class.